Alright guys, today we have LeetCode contest, and according to my calculations, let me show you, I actually believe that this contest is going to be my 100th rated contest. Not on LeetCode specifically, but if we consider all platforms where we participate, so like CodeForces, CodeChef, AdCoder, LeetCode, binarysource.com, then I have a total of 100 rated contests. Now, of course, I participated in many unrated contests on CodeForces and on CodeChef as well, I believe. So yeah, like overall, if you count every contest, then probably the number is higher. But in terms of rated contests, we have some sort of an anniversary here. Last contest, I became, I don't know, my rating got to 2600, as you can see. So let's hope that today we can prove and improve on that result. Biweekly contest should be good for us, because obviously time is good. It's not like 5 in the morning, it's 5 in the evening, so everything should be fine as long as we don't do anything stupid. Which we may do, but let's hope that we don't. Let's hope that we don't. The problems. Okay, problem A. Substrings of size 3 with distinct characters. A string is good if there are no repeated characters. Given a string S, returns the number of good substrings of length 3 in S. If there are multiple occurrences of the same substring, every occurrence should be counted. Okay, substring continuous. Okay. So one stupid way to check that substring is good is obviously cast it to set and then check length. int. I believe that count function works like, so that's like counting, right? 1 and 4, the results appear to be correct, and I think that we also count the last occurrence. Let's quickly check if it's so. Like, this is not inclusive, so we indeed get length 3. I can just double check it. Okay, range n-2, so the last value that I will get is n-3, and therefore I plus 3 will be n, and n is not inclusive, so everything should be fine. And also in tests we have ABC, which ends on good substring. Let's just add empty substring. Invalid test case, size should be at least 1. Okay. Let's add something like this. We got the answer of 0. I think it's everything's fine. Yeah, we get accepted. Problem B, minimize maximum pair sum in array. The pair sum of pair A, B is equal to A plus B. Obviously, the maximum pair sum is the largest pair sum in the list of pairs. For example, if we have pairs 1, 5, then maximum pair is 8, 4 plus 4. Given an array nums of even length and pair up the elements of nums into n over half pair such that the maximum pair sum is minimized. I see no reason why we can't just sort in pair largest with smallest. Obviously, like this should work. And I think that it will work. Yeah, I'm pretty sure that we can just do that. Now, ideally you would like to prove the result that everything's fine, but here we won't do that. N over 2. What do we want here? We want to say that minimum gets minimum of m and a not I. Here we want to return the minimum. That not I is the I square element from the end. It takes a long time to run it. I'm not sure why exactly, but the answers are 2 and 2, which are not correct. Obviously, I wanted to add elements here. Takes a long time to run. That's not good. I mean, it must be that server is quite highly loaded. 7. Oh, okay, of course, because we're minimizing the maximum value of these bodies. Elements are at least 0. Yes, the minimization part happens in sorting. Why does it take so long to run it? 7 and 8. I'm pretty sure that's what you do. Like there should be no better way. Because maximum element gets at least that guy as a pair. Yeah, you can just consider the pairs of bigger half. That should work. That should work. I think pending doesn't mean that it's running, or it does. I mean, this should not be a problem because, like we've seen, yeah, judging is when it's running, and it got accepted. Okay, so clearly the server is quite highly loaded. I don't know why exactly, but okay. Wow, that sounds bad. It looks bad. It doesn't sound because we didn't read anything yet. We're given an m times n grid integer matrix grid. A rhombus sum of the sum is the sum of the elements that form the border of regular rhombus shaping grid. Okay, so all of these guys and all of these guys. For some reason you do. Okay. And oh, okay. So violet is also purple. Purple is also a rhombus. The biggest 3 distinct rhombus sums in grid in descending order. Wow. How large is the grid? 100 times 100. Okay. How many rhombus there are? That's one thing that I can ask here. I'm pretty sure that there is at most 1 million rhombus, because the center can be any square and then the size of the rhombus can go very big. The problem though is that you cannot compute the sum of the rhombus in constant time unless you are smart. When exactly are we smart? Let's question this. Now, The boundary suggests that we should consider that the boundary is difference of like large rhombus and then one smaller rhombus with their like inner part, and yet I don't see how to compute it efficiently. It sounds like some strange, some very strange thing, like you have to rotate by 45 degrees and then you compute prefix sums and you get whatever you wanted, but it just looks so disgusting. I don't even want to. Okay, let's read the D and then we'll see. Given two integer arrays nums1 and nums2 of length n, the XOR sum of the two integer arrays is element-wise XOR sum. Rearrange the elements of nums2 such that the resulting XOR sum is minimized. Okay. They are not particularly long. They are not particularly long. Now, one thing that I can think of is that we want to do it bit by bit. But honestly, it may be the case that we want to solve this problem first, actually. I just want to make sure that... Yo, what? 7 minutes ago? You must be kidding. No. We don't trust this, guys. Now that may be a thing. No, okay, that is just scam. Okay, so good thing that we know that this is not a Googleable problem, so therefore we should just focus on solving it. And I really don't know what is the best way to implement it for once. The boundary of the rhombus is the difference of two filled rhombus, right? And two filled rhombus should be, there should be a reasonable way to calculate them. I'm not sure why would we want just three biggest rhombus sums. I just don't want to do all of this rotation and suffering. That sounds so bad. There must be an easy way around it, surely. Oh, that's not good. That's not good. We're spending a lot of time here. Bro, that is not good. This is not the problem that you want to see in a LeetCode contest. There is a problem. We cannot just loop over all guys. Loop over all rhombus and compute their sums with the for loop. It's going to be simply too much, because to compute a sum of one rhombus. Oh, actually rhombuses are not big, right? Maximum rhombus size is actually half of that thing. You only get them towards around the center. Okay. Okay, I just don't want to find out that naive solution works, because that would be a shame. But honestly, like, the constant appears to be really good in this problem. Because most of these centers are located on the boundary, and then they have only like one rhombus in them. So it appears to be good. Like, I don't know, 1/24 if constant is reasonable, then we can just loop over everything. I mean, here we have to be really careful. K should be less than or equal to I, K should be less or equal to J, I plus K should be smaller than N, and J plus K should be smaller than N plus K. At I minus kj plus grid I plus kj. And there is nothing, and then else gets incremented by grid I minus L j minus bro. I should write plus L. Plus k minus L, and in grid I plus L, g minus k plus L. I suppose that's what you have, like you have Manhattan distance equal to k, because here's L, here's k minus L, here is L, and here is k minus L, but in different direction. That actually sounds like a lot. If L is negative, if L is negative. So L is negative 10 and K is 20. And we get here J plus 30. We should not get J plus 30. Oh, that's so annoying. Even here to sign L from 0 all the way up to L is actually not from 0. Okay, L from 1. And here J minus K plus grid at I J plus K. Let's hope at least this works. A plus L, J plus, so both plus, right? Then minus, plus. Then what do we get? Then we get, here we should get minus, and here we should get minus. Okay, after all we did, yes, numbers are not reasonably small, so they won't overflow. Oh, we actually should be. Maybe I should not be lazy. Like, worst case scenario, we'll just have to replace that with a faster way to get the sum of the rhombus. But my hope is that the constant is quite good in that problem. Because if you take center of the rhombus to be on the boundary or near enough, there are not many rhombus. There are not many rhombus of that size. And therefore, like, we should succeed. That is a very uncomfortable problem, I must say. Oops. I don't feel comfortable submitting a solution like that. So answers 228, 300. It appears to be correct. But our main concern here is it fast enough? Actually, here for some reason we got is not equal to M1. So this is not equal to M1, and S is not equal to M2. S is greater than M3, then we don't want to do that. Yeah, we only got 1, 7 here, that's correct. 777. In practice, I'm afraid that it may TLE. But let's submit and hope for the best. No, okay, got accepted. So clearly the constant is just great in this problem. As always, got to check that problem is not Googleable. Again, this is incorrect. Okay. Just gotta check that it doesn't work like that, okay? Surely that was posted after the contest started, so. Okay, sounds good. So there are not too many ways to, not too many permutations to that array. Surely we cannot try them all, right? Because that would have been too much. But also we have to try something. Like we will have to loop brute force something, at least something. What is it? Normal intuition would be that we want numbers to pair numbers as close as possible with each other. Right? But you can't sort, because the importance of XOR is not just like distance between the numbers, but you have closer in terms of bits. So let's say we consider, let's just say that, no, okay. If we consider what is the highest bit of every number in first array and in second array, is it on or off? Ideally, we would like to pair guys who have them turned on, right? But there may be a different number of elements in every array that have the highest bit turned on. And if it's different, then we have to decide somehow whom do we want to pair and whom do we don't want to pair. Wait, is there such a thing? Yeah. Mean weight perfect matching. Given a complete bipartite graph K and n with weights UV assigned to every edge, find a perfect matching with minimum sum of edge weights among all perfect matchings. Great. Is a way to solve it using subset dp in off, and I'm also seeing that it's possible to modify the Hungarian. Is it correct? 2 to the 14 times 14 times 14. How long is it? Easy. Subset dp. Okay. Min cost max flow, not what we want. No, that's theoretical computer science. We don't want that. I don't know how to write Hungarian, if I'm honest with you. let's think subset dp, subset dp. For every subset of first set, and every subset of, no, but that's too much, right? That is too much. Okay, probably we want to start writing something. 10 to the 7 times 14. It sounds like 10 to the 9th is a good bounce. Alright, so for first guy we can consider prefixes, and for second guy we consider subsets. Here we go. Here we go. Should I should. I definitely should. Switch to C++. Not feeling comfortable about that, so sorry guys. I mean, last two times I tried to solve LeetCode Q4 in Python, it resulted in TLE. I'm not doing it again. Or maybe I will, but not today. So, our plan is to consider everything here to consider every mask of secondary, and then you think like for every bit, if J has case bit turned on, dp at e plus 1 j should get minimum of dp at I plus 1 mask, and then dp at I mask we take that bit away from it, we do this, and then we say like, okay, AI XOR BK. Return dp at n. This is incorrect, however. It is incorrect. Assume dp at 0, 0 is 0. Answers are 2 and 8, but we got undefined behavior because this guy plus this cannot be represented. Oh. I assume we wanted to see that actually. Hello, excuse me? What went wrong exactly? We accessed something wrong. We accessed something very wrong. where it may have happened. All right, yep, of course. I should just write back, right? Two and 8. So the idea is that we loop over all elements of the first array, loop over all possible masks, loop over whoever is the pair for the last element of first array that we considered if it's in the mask. We try, we get previous mask. If previous mask is valid, then we try to continue with our evil plan of conquering the world. Got accepted just like this, terribly slow. But at least we couldn't fight any problems all night, so yeah, we took 35 minutes, not great obviously. Yep, fell of Ukrainian guys. Not thinking too much, just implementing solutions. I believe that rank hasn't updated yet. Are we gonna get top 100? Yes, we will. So reasonable, like clean, very slow on Q3 because I just thought that you want to be smarter, but you don't. Unfortunately, but yeah, Tlatoani had a rough time with Q3. No, reasonable. I mean, yeah, our boy is just super fast. I don't know, I really should cut down the time of solving the first two problems. And then here I just thought that it won't work, but apparently it works. That is strange. No, like I believe that constant is small, but bro, that's small? Okay. I'm not complaining, I just think that like it may be a better problem if the constraints are harder and then you actually have to do that nested thing. Okay. No, I'm losing to all people whom I know. Okay. Yeah, 71st. Well, better than last time. And last time we gained 29 rating points. I imagine that we will gain approximately the same amount of rating this time. So I still think it was a successful day for us. For example, Larry is having a rough time implementing. I imagine implementing cubic solution for Q3 because why else would you take that long, right? Isaac as well solved the first two problems pretty quickly and then recognized that he wants to solve Q4 instead of Q3. Guys must have a rough time. On the other hand, if you like that Australian guy and quickly understand that Q3 the constant is great, then you can just submit it and then here we go. He could have won actually, if not that back on Q4. That's impressive. That's impressive. I definitely should gain some speed. I don't know how, but I should. Let me just quickly cover all the solutions people requested to explain solution after the contest. So here we don't have to do anything smart because all the substrings are short. You can just quickly check. Like you write a function that checks that a given substring is good, and you take all substrings of your interest, and here you go. Probably there is a better way to check it. Actually, this should be unnecessary. Also, I imagine that you can put it here somewhere, somehow. You clearly can put this here, and you know, if you're good at writing shortcut from the get-go, then you're good. Yeah, like I wanted to do it super safe because of the last time when we got wrong submissions on Q1 and Q2. So yeah, I just wanted to do it like really safe. Although like it should be clear that I'm taking a substring of length 3, just check it. Like it costs nothing, but it costs some time actually, but surely less than 5-minute penalty. That's all I'm gonna say here. So just implementation for Q1. Here again, you need some basic intuition, like you want to sort the array, and that's it. Probably because n is at least 2, you probably can say that something like this is actually what you wanted to write. That actually makes more sense. That's how you get some speed. But I don't really exercise in writing this kind of stuff. I just didn't want to write like this because obviously maximum of an empty subsequence is runtime error in Python. And I'm not risking taking a 5-minute penalty for that. I would rather write more lines and spend like an extra minute than take 5-minute penalty. It's not worth it. Yeah, the idea is that you want to sort. Now, why is an interesting question? I imagine that you can consider all elements. I don't know what is the best way to prove it. Like, there are some very fancy inequalities about like that certain functions attain their minimum or maximum value on a pair of inputs when the input is sorted. Rearrangement inequality, for example, but I don't think that it applies directly here. Probably you can still prove it like this. Consider maximum element and its pair, and then minimum element and its pair, right? It should be the case that the answer does not increase if you swap them. So you have like minimum, then you have, I don't know, minimum is paired with A, maximum is paired with B. What I suggest is let's take maximum with minimum and A with B. Now for like if you look at this pair and this pair, then clearly answer didn't increase, right? But if you look at this pair, oh, this pair is probably just less than this pair element-wise. So yeah, this pair is less than this pair element-wise. So therefore, and this pair has decreased as a result of our operation. So it's always beneficial if maximum and minimum are paired not with each other to pair them and then pair the remaining elements with each other. Because this way you can remove maximum and minimum and consider second maximum and second minimum and pair them, etc. This is the actual proof of why sorting works. Here you just don't have to think, you just have to carefully loop over all rhombus. I imagine this is because all elements on the boundary can be a center of one rhombus. All elements on the second layer can be center to two rhombuses. This way you go all the way to the central square, which can be center of 50 rhombus, if you have 100 times 100 grid. And it sounds like you want to integrate something. What is the area of each such thing? If we divide it in 4 pairs like this, then it will be 4 times 100 minus size. This is how many squares can be center of S rhombuses. You want to sum that expression from S equals 1 all the way up to 50. Is it true actually? Is it true? Minus 2S, I believe. Minus 2S. 101 minus 2S. Something like that. Because for 1, 2s is 2, so we get 99, which is correct, and for 50 we get 1 times 4, which is also correct. And then for each such thing, we are counting the rhombuses here, right? But actually, if you have S rhombuses, the rhombus of size S, we also take S 4 times S units of time. No, exactly. 4 times X units of time to compute its sum. So I imagine this gets multiplied by 4s. I think it may be the case, but I feel like it's more. It should be more. Either way, this is quadratic in S, therefore this sum, which is similar to integral, is cubic in S, and therefore it works. Wow, okay. I believe that the exact expression is different actually, but it may be the case that we just didn't have to think at all and just had to implement that. I just thought that it won't work because it's fairly slow. Because if you estimate naively, then you have n times m square centers. Each can be center of up to n rhombuses, and each rhombus can be computed up to n time. which is not good, because overall you get O times 4, so it doesn't have to pass for n up to 100. It may pass, may not pass if you have too many operations per every rhombus. So I was not sure if it's gonna pass, but if you limit everything accurately, so you don't consider rhombuses which are too big, then apparently it works. Okay. More efficient approach, surely you can solve it faster. If you rotate everything by 45 degrees, so you kinda say like my new coordinate axes are like so. Then every rhombus, this body, this red sink, is difference of this field square and field square which is a bit smaller. So you can compute prefix sums, and then you are able to compute sum of the rhombus in constant time. But that's disgusting. It surely sounds like a code forces problem. Let's go. It sounds like, I don't know, E or F in div2 competition. Very likely. I remember some problem which was like Microsoft logo, the Nanosoft. Yeah, that's what it was. I do remember that problem. That was a terrible problem. Yeah. So like you had to find such patterns in a matrix, and I think it's like not hard but disgusting. And this surely sounds like not like follow-up, but just some person was thinking, what's a terrible question I may give to our interviewee today? Oh, let's just give them rhombus and matrix, right? Because if you want a faster solution, then you have to rotate everything by 45 degrees. I imagine that you have to distinguish white and black cells on the chessboard, so just not something you want to implement. But it turns out that sometimes you just want to carefully count all indices that constitute to the rhombus. The way I did it, I took all corners away and then counted things in pairs of 4. So like I count these 4 vertices, then these 4 vertices, then these 4 vertices, and these guys are counted on their own. Because if you think about every such rectangle, here is the center, so it's like minus x plus x minus y plus y. That's very convenient. And then y is also equal to k minus x. So that's why we have such a for loop. In here we did what we were told by code forces block, subset dp. So for every prefix of the first array, we think like what is the pair to that element, and we consider all possible submasks, also subsets of second array. And we say like, oh, you know what? So let's try this pair, okay? then you actually already know the answer for this prefix and everything that remains from the mask. So in our case, what remains from the mask is L. The fact that we pair this guy with this guy is K. We check that K is actually in the mask, and then we just take minimums and minimums and minimums. That's how it works. So yeah, that is actually a nice problem. And apparently you can solve it with Hungarian algorithm, which I should learn, but probably not today. Still 71st, not surprisingly, because we didn't take any penalties this time. Should have been much faster, but whatever. I will take 71st place. It's better than last time, right? So can't complain on that one. Where are the boys? Isaac and Larry. The boys must think that Q3 requires some syncing when it doesn't. Okay, so Isaac got it after one wrong submission. I don't know why exactly it took him so long, but yeah, maybe because you need to distinguish corners and stuff like that. Actually, by the way, the guy is formally a grandmaster, if you think about it. Not in code forces, unfortunately, but 2400. An alec of grandmaster. Where is Lowry? I don't know. Well, people just skip Q3. Maybe he's trying in Python, and in Python it TLEs. Wow, then we are very smart to change to C++. Quan also having a hard time. Dash. For a second I thought that it's like douche alt account, but apparently not. Dash is a word in English. Okay, so people just think that Q3 is not a good problem, we will ignore it. I respect them, I respect their decision, it's not a good problem. But we do have a lot of acceptance. And this is because all the people who solved Q3 but didn't solve Q4 are below those who solved Q4 but not Q3. Oh, Q4 is getting a lot of solves. File of Ukraine, solving Q3 faster than me. Solving everything actually faster than me. For some reason can't get Q4. Okay. Yeah, I believe I will end the video here because it's not particularly interesting to watch me going through the rank list. I believe that explanations that I did at the end were really helpful. Definitely, if you want to see more of these explanations, I will try to cover every LeetCode contest from now, and potentially more other contests, so you can subscribe and not to miss any further screencasts. That's it for me for today, and see you tomorrow with LeetCode and hopefully some Code contest. Let's see. We'll see. Bye guys.